If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in complex number. So today we will see nth root of a complex number and then we will continue it to nth root of unity. Okay, then let's see this. Okay student, so the topic is nth root of a complex number. So you have seen square root, now we will find nth root. Suppose this is your z, x plus iy, which is also written in polar form r cos alpha plus iota sin alpha. And suppose w is the required nth root. That means you need to find the nth root of z, that is nth root of z, that we have considered as w. So w is equal to z to the power 1 by n. So if I can got the values of w, then that is done for me. So wn minus z equal to 0. So this is an equation which have only n roots because the power is n. So it will have n and only n roots. It is nothing else than n. It cannot be less than n, it cannot be greater than n. So it should have n roots. So you can see here, if I consider w is equal to r cos theta and I sin theta, and this one, that r cos alpha, which was the given one, this is the given one, this I can write 2k pi alpha plus 2k pi, because ultimately because it is theta, and you have seen theta in trigonometric functions, after 2 pi it repeats. So after 2 pi it repeats. So 2k pi is nothing but it is the multiple of 2 pi, k into 2 pi. So it will be the same thing. So this number in general can be written as in this way. Alpha, whichever is alpha, you can write it 2 pi plus alpha, 4 pi plus alpha, 6 pi plus, everything will give you same line only. So that is written here. Alpha plus 2k pi, alpha plus 2k pi. So now this one, so w to the power n means this to the power n. If we apply De Morbi's theorem, so it will be r to the power n cos n theta sin n theta. So you can equate real and imaginary. So what will be your Rn if you compare this one first? So this r will be r to the power small by n. If you take 1 by n, then this will be this one, 1 by n. And then directly you cannot take 1 by n because De Morbi is not satisfied for your fractional power. So this, by comparison, you can see this r should be equal to r to the power n should be equal to r. So this r should be equal to 1 by n. But this you have to be very careful. This has to be a real positive number because r, that is the magnitude or modulus, it is not a negative. So, and it cannot be imaginary, it should be real number. So, and if you compare this one, n theta should be equal to this. So your theta should be equal to this. So this is your theta. Now if you can change the values of k, 0, 1, 2 up to n minus 1, you will get n different values of theta. N different values of theta will give you nw. So that is your n roots. We require n values of w which will satisfy this one. So you will get n values of theta, which each theta will give you different w, because w is this one. R is fixed because r is this one. But you cannot go beyond n minus 1 because if you go k equal to n, which will again bring it back to original 0. Because if you put 0, it was, suppose you put k is 0, so it is alpha by n. Now if you put n here, n, so it is 2 pi, 2n pi by n, so it will be n and cancel 2 pi. So 2 pi plus alpha by n is originally again coming, because if you are adding 2 pi, that means you are doing nothing. You are again coming back to original position. So from n onwards, if you put n, you will get this value. If you put n plus 1, so these values will be repeating. So different n unique values you will get up to n minus 1. So that's why you have written this one. So in a nutshell, if I say the nth root of z r, what will be the nth root of z? R to the power 1 by n cos this one, where you will put the values of k from starting from 0 up to n minus 1. You will get n different values. This also we can written as Euler's methods, that is e to the power I, this one is the theta. So this is the formula you have to remember nth root. In general, if you are asked to find z to the power p by q, so it is z to the power p and then you are taking qth root of that p. So z to the power p can be written as r to the power p cos p alpha sin p alpha plus 2k pi is given for getting the general sense, divided by n, instead of n it is q. This p, because it is power, as per De Morbi's theorem it will come with the angle, so that's why it is coming at p alpha r to the power p, and rest is same. Again you will go up to q minus 1. This one you have to be careful again, this should be real positive value. So if you see this equation omega n minus z, so what is the sum of all roots? Is 0, because sum of all roots is theory of equations, you can treat this by this, that is next one divided by this, so next one is 0, so it is alpha plus beta plus gamma dot dot dot, and product of all roots of complex number, it is minus 1 to the power n into this, because you don't know the last one divided by first one. Last one is minus z. So it becomes minus 1 to the power n plus 1 z. So if your n is odd, then this becomes z. So you can think of now 1 omega omega square, that is cube root of unity. So if you take product of these three, it is 1. So that's why it is positive. If you take square root of 1, this is cube root of 1. That's why if you multiply, it is 1. If you take square root of 1, this is plus 1 minus 1. If you multiply these two, it is minus 1. You can see if it is a 2, n is even, then it gives you minus z, that is minus 1, minus of original number. If it is odd, then it is original number, it is coming back, because it is n plus 1. That you have to be careful. Now if you continue this one for nth root of unity, that was for nth root of a complex number. So if you take for unity, you suppose 1 is given and z you have to find, which is the nth root of this one. It is z minus to the power n minus 1. So here 1 we can write it r cos theta plus I sin theta. This one we can write 0 plus 2k pi to make it in general sense, 0 plus 2k pi, because this was the formula, alpha plus 2k pi by n, alpha plus this, alpha is here 0. You will put it up to n minus 1. Now if you put 0, it is 1. If you put 1, then this is this. If you put 2, then it becomes 4n, which is nothing but square of this one, you can see. Which if you put 3, it becomes 6n, which is nothing but cube of this one. So if you take first one alpha, then it is alpha square alpha cube. So it is interesting, the last one will be alpha to the power n minus 1. So all are just multiples of, it is something of GP format it is making. It is forming a GP. So the nth root of unity is 1 alpha. If you take the first one alpha, then alpha square alpha to the power n minus 1. And you have seen all these placed symmetrically in the circle, that unit circle. P1, P2 represent the nth root of argon plane. If they represent these positions, then all are placed symmetrically on a unit circle. This one we have seen in earlier also, because for cubic function we will see it again here, symmetrically on a circle which radius is 1, because all length is 1. The magnitude of each one is 1. You can see magnitude is 1, magnitude is 1, all are in polar forms. So magnitudes all are same. So it is a unit circle with radius 1 and the center at 0, 0. And they also represent a regular polygon, because they are symmetrically placed, so they will represent a regular polygon. Now if you say now how to place it symmetrically, now suppose your n is 5, so you will have 5 roots. So you divide, so first one will be always 1. 1 will be always there. If you put 0 nth value, it will be always 1. Whatever n it is, if you put k 0, then the first one is always 1, because this side is 1, because I am talking about unit root. Okay. Roots of unity. So first one will be always 1, and then you have to place total 5. So it is 2 pi by 5. You have to divide it symmetrically, because it should be placed in the circle symmetrically. So total angle is 360. So you divide by 5, 72. So 72, 72. So each gap will be 72, 72. And you can see these and these are symmetrical. These and these are symmetrical to each other. You can see this. These values will be symmetrical, because if you see this equation, this is an equation where coefficients are real. Here coefficient is 1 real. Here coefficient is 1 real. So if coefficients are real, then roots are always in conjugate form. So if one is this, another one will be obviously this, because you can see if it is 72 here, here it is 72, 72 minus 72. If it is 144 from this side, it is minus 144. So they are all symmetrically placed. Suppose if you have n4, then 1 will be here, 1 I minus 1 minus I. So plus minus 1 plus minus I, square fourth root of 1. You can see it here, because you want, then 1990 you place. You can see this one we have seen for cube root. If it is 1, then you divide by 360 by 3, 120, 120, 120, 120. This one we have seen in our cube root of unity. So it is interesting. They form a symmetrical placement in a unit circle. So if you add all these things, sum of the roots will be 0. We have seen product of the roots depends on minus 1 to the power n plus 1 into, it can be positive, it can be negative. Positive 1 if it is odd, minus 1 if it is even. We have seen in last example. You see this one, this has all real coefficient, not that one. That one doesn't have real coefficient, because dodgeoid is here complex. But here it is real. Coefficients are real. This is real, this is real. So the root should be in conjugate pair. So you can see if one root is this one, another root one is, if it is 2 pi, first one is if you say 2 pi to the power n, so you will get another one which is minus 2 pi. You see this one will be minus 2 pi by n. If you open it, because it is 2 pi and it will be minus 2 pi by n. 2 pi you can cancel, 2n and n will get cancelled, it will be 2 pi, and another one is minus 2 pi by n. So 2 pi doesn't make any sense, so that is minus 2 pi by n, that means this side. So one is, if one is plus 2 pi n, then another one will be minus. If one is plus, then another one will be minus. Here also, now you can think, if one is plus 1, then from where another minus will come somewhere from this series only. One will be plus minus pi. So 1 will be plus 1 will be minus 1. So these will come from k equal to n minus 1, then the negative terms will come. Similarly, it will come from n minus 2. This one and last one, second one and second last, third one and third last, excluding that one will be same, conjugate to each other. If you like the video, then press the like button and please give your valuable comments in the comment section.